What happens if you open your helmet in space? I'll admit to you all that drifting in space is a fear of mine, even though it doesn't make any sense because I've never been to space. But my brain's pretty creative, so now and then I find myself thinking about what I'd do if that happened to me. And one of my options is simply TUC. Open the helmet. The problem with this idea is that it's even worse than it seems. And not only is it worse, but many people are completely mistaken about what happens. So, if you want to know what really happens when you open your helmet in space, this video's for you. Just before we continue, if you want a t-shirt like the one I'm wearing in the video, now's the time. Space isn't cold. To start answering the video's question correctly, we first need to understand a few things about space. And the first one is that space isn't cold. That probably sounds wrong to some of you, especially to those who've heard that the temperature in space is around -270 degrees Celsius. But that temperature isn't like the ones we're used to here on Earth. Let me explain this properly. Whenever we talk about temperature, we're actually referring to how agitated the molecules of something are. The more agitated, the higher the temperature. The less agitated, the lower the temperature. And the key word here is molecules. Temperature is what we call a macroscopic measure of something. In other words, it's a kind of average of how much energy the molecules making up that thing have. Everything within our reach here on Earth that has a temperature is literally packed with molecules. Even the air you don't see has billions upon billions of molecules in this space here. And what's the point I'm trying to make? In space, we hardly have any molecules to have a temperature. It's an almost perfect vacuum. The effects of temperature. And that's important because there are only three ways to exchange heat: convection, conduction, and radiation. Convection is what happens in your pan when you're cooking. The water at the bottom gets hot and ends up swapping places with the cold water, which usually stays on top. And that doesn't happen in space because we don't have molecules. Conduction happens when you touch a hot surface and it gives you a bit of that thermal energy, sometimes causing burns in the process. That also doesn't happen in space because we don't have molecules. The only possible way to exchange heat in space is through radiation, which is the only one that doesn't need contact between matter to occur. If you were to take a thermometer and put it in space, you'd see it slowly decreasing in temperature until it reaches the -270 degrees Celsius we always hear about. But the reason this happens is because the thermometer is slowly emitting radiation, which is invisible to us, and lowering its temperature in the process. The tragedy of Soyuz 11. Of the more than 650 people who have been to space to date, only 3 have died in space. The 3 were aboard the Soyuz 11 mission. The year was 1971, and the first space station in history, Salyut 1, was in low Earth orbit. A mission had been set up to dock a Soyuz, which was Soyuz 10, to the Salyut station earlier in the year. But the crew had to return to Earth when the docking failed due to mechanical problems. Later that year, a new mission with the same objective was launched, Soyuz 11. The rocket was launched from Baikonur, Kazakhstan, on June 6, 1971. The next day, after a procedure that lasted 3 hours and 19 minutes, the Soyuz and the Salyut station were docked. The 3 crew cosmonauts, Dobrovolsky, Volkov, and Patsayev, spent a total of 22 days in orbit inside the station, breaking all duration records in space until then. Until it was time to go home on June 29, 1971. After a decoupling procedure that went as expected, ground control abruptly lost communication with the crew, shortly before re-entry into the atmosphere. Soyuz 11 continued its way back and 25 minutes later landed in Kazakhstan. in what seemed to be a completely normal re-entry procedure. The rescue teams reported no visible damage on the outside. The only strange thing is that after they banged their hands on the Soyuz fuselage, they didn't hear responses from the cosmonauts who remained in their usual positions. But they had bluish marks on their faces and a little blood coming out of their noses and ears. The cause of death? Asphyxiation. An investigation into the cause of the accident found that the problem was a ventilation valve that was damaged during re-entry. The damaged valve left the cabin open to the vacuum of space at an altitude of 168 kilometers, removing all the air from the interior. All the cosmonauts were gone within 40 seconds. To this day, they are the only 3 people to have died in space, above the Kármán line. The effects of pressure. I told this tragic story of Soyuz 11 to show that the main danger, at least for humans, of space travel is pressure, which is zero in the vacuum of space. The 3 cosmonauts were exposed to the vacuum of space, but temperature wasn't considered a factor in the investigations. They didn't survive precisely because of the pressure, or rather, the lack thereof. The human body has evolved and adapted to a very specific environment, which is what we find here on Earth. We're constantly being crushed by atmospheric pressure. And once you remove that from the equation, we have problems. In the case of the cosmonauts, contact with the vacuum of space caused the oxygen and nitrogen dissolved in the blood to form bubbles that ruptured the veins. And this happened throughout their bodies, but it was particularly problematic in the brain. But the most surprising thing is that we know of a case of a person who was exposed to vacuum and survived. The man who survived the vacuum. In December 1966, NASA was testing spacesuit prototypes. For this, they used a large vacuum chamber, which can remove all the air particles from inside, simulating the space environment. And one of the engineers, Jim LeBlanc, was testing one of these suits inside the vacuum chamber. At one point during the test, the hose maintaining pressure inside the suit disconnected. And 14 seconds later, LeBlanc lost consciousness and fell backwards. Luckily, one of the people who was also in the test managed to enter the chamber 25 seconds later and give oxygen to LeBlanc. And he, to this day, is the only person who was exposed to vacuum and survived to tell the tale. And in his words, the last thing he remembers is the saliva on his tongue bubbling and evaporating. He lost consciousness shortly after. Conclusion. So, to answer the video's question, what happens if you open your helmet in space? You don't instantly freeze, as some movies show. Your body temperature remains until a relatively long time. The main problem of space without the protection of a suit is the vacuum. As soon as you start being exposed to the vacuum, the gases in your blood start to form bubbles that block your circulation and begin to rupture your veins. Most people would have 20, with luck, 40 seconds of consciousness. And a commonly used estimate is that once exposed to vacuum, a human has an average of 90 seconds for recompression. Going beyond that, death is inevitable. In the end, space clearly wasn't made for our survival, but we exist and thrive in it despite that. The existence of an international space station, which is a symbol of cooperation between countries, continuously inhabited by humans for 23 years, is also a reminder of what humanity does best, which is to adapt to live in the most unimaginable places. We didn't evolve to travel in space, land on the moon, or put robots and eventually humans on other planets, but we do all of that despite living in a universe that is especially hostile to life as we know it. And in a future that I hope is very soon, we will be present. We'll be on every moon, every planet, every piece that can be studied in our solar system, our neighborhood amidst the stars. And we'll discover many things, we'll know the impossible, and we'll leave our mark and our legacy among the stars. And that's why conquering space is important. Thank you very much, and until next time.